I told you in class I was going to make a video of me going through the investigative task. Just a reminder again about this question. It will be the last question. You can see that the percent of your Section 2 score is 25%. So I was incorrect there. I thought it was half. So it's only a quarter. So, I mean, still that's a lot. But the thing that's difficult to prepare for this is that you can't really prep for it. I mean, yes, you need to obviously know your statistics content, but it's going to take what you know and try to extend on it in some way. So let's try this one together. You can watch this video. It's not too long. And there are a lot of parts, but some of the parts are pretty quick. And you can see kind of what a question like this looks like. All right. So we have researchers studying two different designs of computer keyboards, keyboard J and keyboard K. And they're hoping to see if this increases the effectiveness of the speed of the data entry. So if you look here, they're saying that they believe there's a tendency for people that enter data with keyboard J to have faster, so smaller, entry times compared with people who use keyboard K. All right, they give us two dot plots for these 5 people with keyboard J and 6 people with keyboard K. All right. Now, first thing I noticed about the dot plots is that you've got in keyboard J and keyboard K what looks like potential outliers. So in question A, when it says, explain why it's not appropriate to conduct a 2-sample t-test for the difference in population means, my first thought is, well, the sample size is extremely small, right? So the sample sizes are small, so we would like our sample sizes to be larger than that. And the dot plots show potential outliers in both data sets. Okay, so that would tell me that it's not appropriate to conduct a 2-sample t-test for the difference in population means. So letter B says, okay, if that's true, then why might it be more appropriate to compare population medians instead of population means? So this goes back to one of the very first concepts we talked about in the first semester in our kind of our first unit, is that if you notice any skewness or any potential outliers, you want to make sure that you focus on using the median and the IQR. All right, so instead of doing the mean or the standard deviation, we use those other measures of center and spread to describe the distribution. So in this case, why is it more appropriate? If outliers are present, then the mean will be pulled that direction. The median, again, we said this, right? I want to be very clear here. It could change. The median could also change, but not nearly as much as the mean. All right, so again, the idea is that the median as a measure of center is more resistant to those that potential skewness or potential outliers. Okay, and that's a concept that you should know from our first unit. Okay, part C. This is when it gets into the that was kind of a you should kind of know that stuff. This is gets out there, if you will. So they have here some information about a test called the Wilcoxon rank sum test, which is a real thing, by the way. And to conduct the test, the entry times for each of these keyboards are combined into one group and then ranked from 1 to your highest, so in this case, 1 to 11. All right, so in this case, we have our entry times, and they want us to complete the table to assign ranks for the observed entry times going in order. All right, so we have the first one is J, because it's 158. Then the next number is 184, which is a part of keyboard K. You have the idea. So after 240, the next number is 248, then 251, then 261, 267, 279, and then 280, all the way up until the last two. All right. Now, if you notice here, 248 is with keyboard J, same with 251 and 261. So the next three are keyboard J, and then after that, those are all keyboard K. Okay. So it says use the table we completed to find the sum for the ranks for keyboard J and for keyboard K. So for keyboard J, I'm just going to add up all those ranks for keyboard J. So it's 1 plus 3 plus 4 plus 5 plus 6. Yep. All right, so that's going to be, let's see, 8 plus 5 30, that's 19. Then for k, it's 2 plus 7 plus 8 plus 9 plus 10 plus 11. So a lot more high numbers here. All right, so that's 9, that's 17, 26, 36, so 47 for the sum of ranks for keyboard K. All right, now here are the hypotheses to run this test. We assume that the median for each of these distributions, so keyboard J and keyboard K, are the same, and we want to prove that the median distribution for the entry times for keyboard J is actually smaller or less than the median of the distribution of the entry times for the users of keyboard K. All right, here's how they find their test statistic. Again, we've talked about test statistics in our class before. We had our z-score, our t test statistic with the student's t distribution model. We had chi-squared as a test statistic. So lots of different ones. We've never had one called W, so this is that extension. So W is found by taking the sum of the ranks for letter J, which is, we just found, which was 19, right? So that's that value there. Minus, and it says the number of data sets, or I should say number of data values in keyboard J, which was 5. So minus 5 times 5 plus 1 over 2. So that's 19 minus, let's see, 5 times 6 is 30. Divided by 2 is 15. So our test statistic here, test statistic for W is 4. All right, next page. All right, so here they give you the sampling distribution for all the possible values of W. Remember, ours right now is 4. We're going to get back to that for the last part. Part E says the least possible value of W in this distribution, right down here, is 0. So what would be the value for the sum of the ranks in keyboard J to make that true? So let me write down the formula again. It was W equals the sum of the ranks of J minus the number of data values for J times number of values of J plus 1 all over 2. Okay? So that would mean that this needs to be right underneath. This is 0. I don't know what this is. I'm solving for it. Minus the same thing I did before.
Teachers, please excuse.
Which is, oops, sorry. Which is 15, right? The 5 times 6 divided by 2 is 15. So in order for this to be true, the sum of the ranks for J needs to be 15, right? So that's what I'm looking for. So it's saying, okay, reorder, so reshuffle the table to make this true. Well, what I noticed when I was doing this is that if you did the first 5, right, remember there's only 5 keyboard Js. If you do the first 5, that's 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15. So the way to get 15 is just do the first 5 ranks. So that'd be the 5 lowest times. Then K, all the way for the rest of them. Okay? Now, the last part here is to get back to what we did in part D when we found our W is 4. All right, that's our test statistic. So if we go to that sampling distribution model, right, you can see that 4, right, out of 462 of these possible assignments has 5 where they're at 4. And if I go proving this has a smaller data entry time, smaller median time for the data entry, I want to do values of 4 or less. So essentially, if I highlight here, I'm doing all of these parts of the histogram. Okay, so if I were to calculate this up, that has 5 from the number 4 histogram, plus 3 is 8, plus 2 is 10, and 11, and then 12. Okay, so out of 462 possible assignments, 12 of them have a test statistic of 4 or less. So essentially, I'm going to do 12 divided by 462 to get 0.026. All right, and this is what we call our p-value. All right, comparing that to an alpha of 0.05, you'll notice our p-value is below alpha, so we do have enough evidence to say that the median distribution, I should say the median of let's say the median entry time. There we go. The median entry time for the distribution of all keyboard J users, keyboard J users is less than the median time for all keyboard K users. And that is it, guys. All right. So again, some of this stuff you'd be like, oh yeah, I can definitely do that. Some of the stuff is a little tricky, right? That's what I was trying to show you, that with the investigative task, it takes what you know and tries to pull it a little bit further. Okay. Good luck on this one.